So this is lesson 2.7. We're going to start off with reviewing what we learned in chapter 1 about the segment addition postulate. And we're going to be able to use this for justification in many proofs. So we have AB plus BC is equal to AC. The left plus the right is equal to the total. So that is the segment addition postulate. We can use that as justification in proofs. And just a reminder that we have our reflexive, symmetric, and transitive, we can actually use these properties for congruence as well, not just of equality. So segment AB is congruent to segment AB by reflexive property of congruence. AB is congruent to CD, then CD is congruent to AB, where we kind of flip it and it's symmetrical, symmetric property of congruence because we're using congruent symbols here. And the same thing with transitive. So let's take a look at our first two-column proof here. And we always start with what? We always start with our given. So we're going to split up our given here, and we're just going to put, oh, sorry, we only have one given. There it is. That's our sentence of what we're trying to prove. So segment AB is congruent to segment CD. Now, what we're going to do from there is we're going to use what we talked about up above. We're going to use our definition of congruence. We already talked about that if something's congruent, that it is equal. So we want to go to saying that it is equal because we're trying to end up with AC and BD. Okay, so now we can move to our reflexive property, saying that BC is equal to BC. And then we can move to our segment addition postulate. So we've got all this stuff above the segment addition postulate because we're going to need to use our segment addition postulate to probably substitute some things in. So segment addition postulate, we can say that AB plus BC is equal to AC. And then substitute in, since AB is equal to CD, we can substitute in CD here. And then we can go ahead and do segment addition for this part. CD plus BC is equal to BD. Okay. And then we can use the transitive property. So if this is equal to AC and this is equal to BD, then these are equal by the transitive property. Or substitution is also fine. And then if something is equal, then it is congruent. So when it comes to the segment addition postulate, we have to use equal, so that's why we changed our congruence to an equals here and used equal, and then we changed it back. If something's equal, it's congruent by definition of congruent segments to get our what we were trying to prove. Okay? All right, let's take a look at another one. Now, one thing that it helps again, is to always start with what you know, which is the given. So put your given in there. And then you can also fill in the end piece, what you are trying to prove. So we can put that as our step 5. Now we can't put the reason yet because we're going to work our way through that. Okay, so let's take a look. And I put these two first because these both have CD in them. So if we can say this is congruent to CD and this is congruent to, BC, then this is congruent to this by what property? The transitive property. So now we can go ahead and give our other given in here. And now we can kind of see, oh, look, these both have an FH. So what can we do there? Well, again, our goal is to get AE and GD, so we can go ahead and put these congruent because of the transitive property. And then, well, it's not in the right order. So to get it in the right order, we can go ahead and flip it by the symmetric property. So one step at a time, trial and error, kind of how it works. All right, our next one is going to be a paragraph proof. So let's just go ahead and start off with what we do know, and it's what we're given. So we're given that AC is equal to AB is equal to BX. Well, if they're both equal to AB, then we can say that AC, the first and the last there, are equal to each other by the transitive property. And if we are given our other little piece of information here, CY is equal to XD, that's given. Then look and see what we have kind of prior to. Well, by our addition property, because we're going to be adding up some segments here, we could say that AC plus CY is equal to BX plus XD. Okay, and so then AC plus CY is equal to AY, because we know that these two are equal to AY. So, we're adding the same thing to both sides here. It's the addition property, not segment addition. So we're adding CY and XD, what we had just given as equal. We can add those to both sides. So now we can go ahead and see, well, AC plus CY is on that left side, BX plus XD. So we've got some things we can kind of replace if needed. But let's look at that segment addition. AC and CY is equal to AY. So that might help us because we've got this. So we now know what it's equivalent to. And then let's go ahead and do segment addition for this part, BX and XD. That's equal to BD. So now we can go ahead and replace this with AY and this with BD by substitution. And now we've got it, what we were trying to prove. So look to see again where you're starting with, what you have. Always look at your picture, label parts if you need to, and then kind of play around with how you're going to get to it for the middle steps.